nicknamed the rainforests of the sea. Coral reefs, bursting with a brilliance of colors. They cover less than 1% of the sea floor, but comprise complex and diverse underwater communities, home to 25% of all marine life.
A fascinating ecosystem on the planet.
Stuart Sandin is a professor at Scripps Institution of Oceanography at the University of California, San Diego. He's been studying coral reefs for 25 years.
If you jump in the water in one location of a coral reef, you're likely to see hundreds of species of fish, hundreds of species of corals, and countless number of little invertebrates. Just that vast diversity packed into a tiny place makes it just a bastion of life.
And a crucial buffer against erosion and storm surges.
That coral ecosystem also serves as a break from the intensity, the strength, and sometimes the overwhelming power of the ocean. Breaking waves, dispersing that energy, and protecting coastal ecosystems.
But warming temperatures are threatening these valuable and vulnerable colonies, causing the corals to expel the symbiotic algae living in their tissues and lose their bright colors.
The corals are having some trouble adapting to the heat. The animals that live in the coral reefs with no corals have no home. So there's a big worry out there about what the future of coral reefs will look like.
What that future looks like is the vision behind the 100 Island Challenge, an initiative run by Sandin and his team in a collaboration with 19 countries around the world.
These two kind of have similar structures.
And we got to see it with our own eyes. In this lab, coral reefs from 100 islands across the Caribbean, Indian, and Pacific Oceans come to us.
How do we actually drain the oceans to reveal what is out there?
Answering that question is another member of the team, Falco Kuster, an engineering professor at the university. He's using artificial intelligence to develop algorithms to analyze and identify nearly 1 million corals across the 100 islands. It works by stitching smaller digital snapshots together to build these stunning 3D models.
Capturing 1 million plus point for a single square meter, rather than the 10 points that we would get if we go to our online Google Maps.
That resolution allows the scientists to monitor over time and in minute detail how corals are growing, shrinking, living, and dying, a far cry from traditional methods.
1 or 2 people would get in the water, they would observe things, write something down on a piece of paper, underwater paper, and then record that and then create a graph and tell the story of what they observed.
The technology has been transformative, allowing the team to see coral reefs in a whole new light.
It's like identifying your favorite child, right? There's really no such thing. Every single one of these sites has a truly unique story to tell.
The stories also revealed a stunner, an unusually positive anecdote in the climate change narrative.
We're actually finding that there's some corals that are suffering the effects of climate change, and that community of corals grows back stronger. It grows back with more of an ability to face high temperatures than their predecessors.
The team is now investigating why some corals are so resilient and what that says about the future health of these kaleidoscopic communities amid a changing planet.
If we lose them, we lose a part of our humanity. We have to build a new relationship with our natural resources if we want to maintain some of this beauty, this wonder, and the productivity. So we have this unique opportunity to think about how the world around us has changed, and more importantly, how do we navigate it for the next generation so that we preserve the things that are important to us as humans and as a society.
Frances Coe, CGTN, San Diego.